Hello guys, welcome back to my YouTube channel. If today is your first time, kindly subscribe and turn on the notification button to be notified anytime I upload a new video. Also, don't forget to share this video. Thank you. In this tutorial, we are going to resolve the following forces into their vertical and horizontal components. The question says, the following forces act concurrently on a particle: 60 Newton due west, 55 Newton at 50 degrees west of south, 30 Newton at 40 degrees east of south, 40 Newton at 180 degree, 65 Newton north 58 degree east, 57 Newton north 62 degree west. Using analytical method, find the magnitude of the resultant force and state the bearing. So solution. The first thing to do is to make a neat sketch of all the forces acting on the body. So we start. This is our north, this is our south, this is east, and this is west. The first force is 60 Newton due west. 60 Newton. Then the second force is 55 Newton at 50 degrees west of south. West of south. This is 55 Newton. And west of south we have here as 50 degrees. The next force is 30 Newton at 40 degrees east of south. East of south, east of south. So the next force is here. And it's 30 Newton east of south. We have here as 40 degrees. The next force is 40 Newton at 180. This 180 is a three-figure bearing. So we start from the north and move clockwise 180. Therefore, the force is acting due south. So here is 40 Newton. This force is 65 Newton. North 58 degree east compass bearing. This is north, this is east. Therefore, the force is here. And it is 65 Newton. North, we have 58 degree. Then this one is 57 Newton, north 62 degree west. North 62 degree west, which is this part. Here is 57 Newton, and it is 62 degrees. So these are the forces acting on the particle that's at this point. So we are going to resolve these forces into their vertical and horizontal components using the angle of inclination of the forces with the horizontal. The angle of inclination of 65 Newton with the horizontal is here. For us to know this angle, from here to here is 90. So we subtract 58 from 90, which is 32 degrees. So here is 32 degrees. Same thing applies here. From here to here is 90. For us to know the angle of inclination of this 57 Newton with the horizontal, we subtract 62 from 90, which is 28 degrees. The same thing is here. The angle of inclination of this 55 Newton with the horizontal is 40 degrees, which is 90 minus 50. This one too, the angle of inclination of this 30 Newton with the horizontal is 50 degrees. So to resolve this, we say that our h which is horizontal component, is equal to F cos theta, and our V, which is vertical component, is equal to F sine theta, where theta is the angle of inclination of each force with the horizontal. Summation of all the horizontal forces is equal to 0, such that forces to the right are taken as positive and forces to the left are taken as negative. Therefore, our summation of H will now be equal to, now in summing up all the forces, the sign convention is very, very important, because if you miss it, all your calculation will be wrong. So we must follow this our sign convention that we stated here. For this 65 Newton, for us to know the sign convention, if we close this angle by dragging this force down, the arrow is pointing towards the positive direction. Therefore, the force is positive. So we now say 65 cos 32 degrees. The next force is 57 Newton. If we close this angle, the arrow is pointing towards the negative direction. Therefore, our 57 Newton force is negative. We have minus 57 cos the angle, which is 28 degrees. The next one is 16 Newton. This 16 Newton is a horizontal force. It has no vertical component. Therefore, and is pointing towards the negative direction. Therefore, our 16 Newton force is negative. We have minus 60 Newton. The next force is 55 Newton. If we close this angle by dragging this up, the arrow points towards the negative direction. Therefore, this 55 Newton is negative. So we have minus 55 cos the angle, which is 40 degrees. This force is 40 Newton. It's a vertical force. It has no horizontal component because cos 90 is 0. So we'll now say minus 40 cos 90. The next force is 30 Newton. If we close this angle, the arrow points towards the positive direction. Therefore, this 30 Newton is positive. We now have plus 30 cos 50 degrees. Therefore, our summation of H will now be equal to 65 cos 32 is 55.123 minus 57 cos 28 is 50.328 minus 60. Sorry, this n is not supposed to be here. So minus 60 minus 55 cos 40 is equal to 42.132 minus 40 cos 90 is equal to 0. Then plus 30 cos 50 is equal to 19.284. So our summation of H will now be equal to, if we add up everything, we have minus 78.053 Newton. For summation of V is equal to 0, such that upward forces are positive and downward forces are negative. Therefore, our summation of V will now be equal to, the first force is also 65 Newton. If we close this angle, the arrow is pointing towards the positive direction. So the force is positive. Therefore, we have 65 sine 32 degrees. Then this is the next force. If we close this angle the arrow is pointing towards the positive direction. Therefore, this 57 Newton is also positive. When I say plus 57 sine 28 degrees. The next force is 60 Newton. 60 Newton is a horizontal force. It doesn't have vertical component because sine 0 is 0. Now say minus 60 sine 0 because the angle of inclination of this 60 Newton with the horizontal is 0. So the next force is 55 Newton. If we close this angle by dragging this force to this direction, the arrow points towards the negative direction. Therefore, our 55 Newton is negative. So we have minus 55 sine 40 degrees. This is a vertical force. It has no horizontal component. So, and it's pointing downward. So we have minus 40. The next force is 30 Newton. If we close this angle, the arrow points towards the negative direction. Therefore, 30 Newton is negative. So we have minus 30 sine 50 degrees. Summation of V will now be equal to 65 sine 32 is equal to 34.445. Then plus 57 sine 28 is equal to 26.760. Then minus 60 sine 0 is 0. Then minus 55 sine 40 degrees is equal to 35.353. Then minus 40 minus 30 sine 50 is equal to 22.981. Summation of V will now be equal to, add up everything, minus 37.129 Newton. So we now draw our cardinal point again to locate the two forces. Here is north, here is east, here is south, here is west. Now, we have established that forces to the right are positive and forces to the left are negative. And also that upward forces are positive and downward forces are negative. This part is positive, here is positive, here is negative, here is negative. Our summation of H is negative, therefore the force is acting in this direction. So our H is 78.053 in Newton. Then our summation of V is also negative, meaning it is acting due south also, which is 37.129 Newton. So our resultant force lies between the south and the west. We draw our resultant force, arrow. And theta is the angle of inclination of the resultant force with the horizontal. If we form a triangle here, we say that this side is equal to this side and this side is equal to this side. Therefore, our arrow, which is the resultant R, will now be equal to square root of summation of H all squared plus summation of V all squared. Therefore, our arrow will now be equal to square root of minus 78.053 all squared, close the bracket, then all squared. Then plus our V is minus 37.129 squared. If we sum up everything, arrow will now be equal to 86.434 Newton. So So this is our resultant force. For us to find the direction, we use tan theta. To find our theta, we say that tan theta is equal to opposite over adjacent, where this side is our opposite, which is equal to 37.129, and this side is our adjacent, which is equal to 78.053. So this will be equal to, which is 37.129 all over adjacent 78.053. Theta will be equal to 0.4757, where theta is equal to arctan 0.4757. Theta will now be equal to 25.44 degrees. Therefore, to state the bearing, we say that the resultant force is 86.434 Newton on a bearing of 25.44 degrees south of west. So this is our final answer. Use the link on the screen to watch method 2 of solving this same problem. Thank you.